I want to turn to another set of heuristics that we use. And this is a heuristics that are sort of evolved behaviors that are used in forecasting. And essentially forecasting is predicting the future. Really, this is about probability judgments. We're trying to anticipate what might happen in the future and estimate probabilities associated with things. Sometimes we just do this intuitively. We're not actually writing down a probability, but we're judging, what's more likely to happen in the future. And so, this, of course, is something that we have to do anytime we make a decision. We're always forecasting the future when we're making a decision. And so it must be that we've got innate cognitive techniques for how we do this. Well, what are those shortcuts we use when we're doing forecasting, and what kind of biases can they lead us to? Well, there's three common heuristics in forecasting that psychologists have identified. They're called the anchoring heuristic, the availability heuristic, and the representativeness heuristic. And let's look at each of these in turn. The idea of anchoring is that what we do in estimating a probability or estimating a likelihood or a consequence is that there is some starting point, some starting guess that we make, and then we adjust around that. So the difficulty with anchoring is that it is substantially influenced by the starting point, and the adjustments you make are often limited by the starting point. So for instance, here's a great example. This was a study that some folks did. They sampled a lot of students, divided them into one of two groups. And they said, for group one, they said, I want you to estimate this product, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Estimate what that is. And they just gave them a short period of time to estimate that number. Group two, they gave what is essentially the same problem, but they put it in a different order, 1 times 2 times 3 times 4, etc. And the average product that these two groups gave, group one, the average was 2,250. The average for group two was 512. Well, how did this arrive? Well, think about it. Okay, if I was doing this and somebody said, quickly estimate this product for group one, I'd say 8 times 7 is 56. 56 times 6 is like, I don't know, 300. 300 times 5, I get it 3 times 5, 1,500. Okay, yeah, it's around 2,000, 2,500, right? I don't finish out all the multiplication, but I get an estimate that way. If I'm group two, I go 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24. Boy, this is not a very big number. 24 times 5 is around 125. Okay, so 500. And so what's happening is we're creating a starting point by looking at the first two numbers, the first product, right? And then we're kind of adjusting to deal with the rest of the complexity of the problem. But the difficulty here is you can see group one is anchoring on 8 times 7 is 56. Group two is anchoring on 1 times 2 is 2. So they've got a very different starting point, which leads to a different ability to do adjustment and therefore a different estimate. And in fact, the true product is quite a bit larger. It's 40,320. And so in all cases, both groups are failing to do the adjustments necessary from their starting point. In some ways, this is a status quo bias, right? Whatever influences us as an anchor has a very strong sort of influence. Now, this is fascinating. When you're working with experts, say you're working with an expert group, and you're trying to estimate the probability of extinction for some species that nobody's done a population viability analysis on because there's not much data out there for it. So what you've done is assemble all the world experts on this, and you're going to go through some formal expert elicitation techniques. And let's say you phrase that as the problem, you help them think through that. And what if somebody says to you, well give us I don't exactly know what you mean by probability of extinction, give us an example. And then you as a facilitator say something like, well, you might say something like the probability of extinction over the next 100 years, the probability of the population dipping below 50 animals in the next 100 years is, say, 95%. Okay, you've just done a huge amount of anchoring. They may know that was a hypothetical example, but they now hear 95% swimming around in their head. And so when they go to think about their case, they're going to think, okay, well, the 95% must be the kind of answer I'm looking for. Now, let me think about this particular butterfly or whatever, and I'll adjust around that to make it customized to that. Well, they've already anchored on that. So there's some important things about how we discuss these questions of forecasting to guard against this inherent tendency for anchoring and adjustment. Because what it leads to is conservatism and overconfidence. Interestingly, there's a lot of study of experts when they're asked to do forecasting. And experts as a whole tend to underestimate uncertainty quite a bit. They tend to be overconfident in their answers. And essentially what that is they're doing all their work and coming up with their first guess. And then when the second step is to say, well, how might you be wrong? They're already anchored on that first, first guess, that starting point. And so it's very hard for them to think outside that. So you end up with an underestimate of uncertainty and overconfidence. Now this is reduced with repeated experience, if experts have repeated experience with feedback on their predictions. And so weather forecasters, for instance, when they've been studied as a group, really make very good forecasts, and they don't tend to be overconfident at all because they are trained. They make forecasts every day, and they find out 24 hours later whether they were right or not. And so they have repeated experience with feedback on their predictions, and so they can learn about the degree to which their initial guess or their predictions are likely to be right, and they can frame their uncertainty appropriately. But in general, the average expert does not have that skill. Another thing that anchoring leads to is the overestimation of the probability of conjunctive events. Conjunctive events are ones that occur together. So if you've got, if this has to happen and this has to happen, we tend to overestimate the probability that both will happen. So if you look at question 6 on your quiz, question 6 said, for a communication system to work, each of the 7 independent relay centers must be operational. Each center has a 90% probability of being operational at any given moment. You're about to send a message. What's the probability it will reach its destination? Well, this is a conjunctive event because it will only reach its destination if all of the relay centers work, all 7 of them work. Well, what's the probability that all 7 are going to work? Well, the probability that one of them works is 90%. So what do we think? Well, the probability it gets through the first one is 90%. The probability it gets through the second one is another 90%. Well, I'd have to multiply those together. 90% of 90% is 81%. Okay, well, what's the total probability for all 7 events? I may estimate that and say it's something like, I don't know, 70%, something like that. But in fact, it turns out it's 48%. What I need to do is take 0.9 to the power of 7. 0.9 times 0.9 times 0.9 times 0.9 times 0.9, 7 times, right, for each of the relay centers. And that ends up being 48%, which might be surprisingly small to you. And that's because what happens is we anchor on that 90%. That's our first estimate, is the 90%. Our second estimate is the 81%. And we anchor on those kind of biggish numbers and don't make enough adjustments to get to the probability of the conjunctive events. So anchoring leads to that. Anchoring also leads to underestimating the probability of disjunctive events. Disjunctive events are events separated by an or. This has to happen or this has to happen. Let's look at question number 8, which says, suppose a chemical plant will leak dangerous fumes if at least one of the 10 independent subsystems fails. Each is designed to have only a 1 in 100 chance of failing in the course of a year. What's the probability of leakage? So we get leakage if the first one fails, or the second one, or the third one, or the 8th one, the 9th one, or the 10th one. This is a disjunctive event. Any of those happens, any one of those happens, and we get a failure. What's the probability of leakage in the next 12 months? Well, the probability of leakage on the first one is 1 in 100. On the second, it's 1 in 100. So what's the probability of one or the other happening? Well, it's about 2 in 100. Okay, that seems pretty small, right? So I might not really, I might say this is, I don't know, 3 or 4 or 5%, not very big. In fact, it's just short of 10%. It's about 9.5% probability of any one of them leaking, and of at least one of them of them leaking. And so here's a case where we tend to underestimate the probability of disjunctive events, again, because of the anchoring heuristic. We're thinking about the 1 in 100, we're using that as our starting point, and we're failing to adjust for all the disjunctive events that could occur. Okay, so that's an example of, another example of how anchoring can lead us astray when we're doing some forecasting. The second heuristic we use in estimating probabilities, in forecasting the likelihood of events, is called the availability heuristic. And in the availability heuristic, we tend to estimate probabilities based on how easily we can think of examples of them occurring. And the interesting thing is, our ability to recall something is best for events that are vivid, that are recent, that are unusual, or that are newsworthy. And that vividness may or may not be correlated with the actual probability of them occurring. So here's an example. Are earthquakes more common in California or Alaska? Which is it? Turns out they're way more common in Alaska than they are in California by orders of magnitude. A very severe earthquake of magnitude, I think 7 or above, occurs about once every 9 or so years in California. It occurs, on an average of once a year or more in Alaska. The number of earthquakes that occur in Alaska is many times larger than the number that occur in California. But why do we tend to think about California when we think about earthquakes? Well, the human population in California is quite a bit larger than it is in Alaska. And so when there is an earthquake, the event is more vivid, there's more media coverage of it, we hear about it, there's usually more consequences to it than when an earthquake occurs, particularly in sort of rural Alaska where there's very little habitation. And so the availability of the information is quite different in these two cases. And so we might misestimate these probabilities because we're basing it on the availability heuristic. Now, the availability heuristic makes sense when our ability to recall these events is equal among alternatives. Then we might do a good job of forecasting. But we've got to be aware of when this might not be the case. Another example I think is sort of fascinating is what's more likely? Are you more likely to get bit by a snake in the United States or hit by a piece of an airplane that's fallen off? This one I found fascinating. Well, it turns out you're more likely to get hit by a piece of an airplane that's fallen off than, not a big piece, but a screw or a bolt or something like that, than you are to get bit by a snake in the United States. Now, we don't hear about people getting hit by things falling from an airplane, but the snake bite is sort of more of a vivid kind of thing, and we hear stories about it, we tell stories in our childhood about that, and we develop this sort of vividness of this event that's not actually correlated with the frequency with which it occurs. Okay, another example of the availability heuristic. Now, the availability heuristic may be misleading, of course, when the event we recall has limited relationship to the probability of an event occurring in the future. We tend to underestimate events that are difficult to imagine. It's difficult to imagine a bolt falling off an airplane and hitting me. And we tend to overestimate events that can be easily recalled. So yet another example, if you look at question 1 in your quiz. Question 1 says, in the US, which cause of death is more likely to occur? A stroke or an auto accident? Well, auto accidents tend to be newsworthy. They tend to get written up in the newspaper or whatever the news outlet we use is. Whereas, a stroke is not a news event. Well, strokes are a much more common cause of death than auto accidents. But we just don't recall them because they're not reported in the same kind of way. The third heuristic we use in making forecasts, estimating likelihood of events, is what's called the representativeness heuristic. And it's a tendency to judge events by their degree of similarity to other familiar events or to some stereotypic image. So the trouble with the representativeness heuristic is it can lead to ignoring the inherent probability of events, these so-called base rate frequencies, and it can lead to expecting sequences of events to appear random. So let's look at question 2. Question 2 says, which coin toss sequence is less likely? We have it heads, 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 tails, 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 or tail, tail, heads, heads, tail, heads, tail. Well, what is the probability of these two sequences? It's actually equal. There's an equal number of heads and tails for each of these, and so the probability of either of these sequences is the same. But we tend to expect sequences of events to appear random. And so the first one doesn't really look random to us. It looks too ordered, right? So we don't think of that as being representative of a sequence of coin tosses. Okay, so we think that's not very likely. So there's an example of where representative leads us, that heuristic can lead us astray. It also can lead to ignoring the odds that outlier events will be followed by less extreme events. This is a pattern called regression to the mean, and is exemplified by question number 4. So question number 4 said, during the summer, breweries' sales of canned beer are largely influenced by chance events, such as weather or sporting events, etc. In the first week of August, there was exceptional sales of 1.2 million cans. In the absence of any other information, would you judge that it's more likely the sales the following week will be higher than 1.2, about the same, or lower than 1.2 million? Well, this was an extreme event. This sales of 1.2 million was an extreme event. And so without any other information, we would expect that the subsequent week, things will return more or less to normal. So it's more likely that that beer sales the next week will be lower than 1.2 million because it should regress to the mean. This idea of regression to the mean, I mean, this is a kind of expectation that we sort of have built in about probabilities, and it can lead us astray. Another way that the representative heuristic can lead us astray is by expecting the probability of joint events to be greater than the probability of the component events. This is called the conjunctive fallacy. So question 5 gave you an example. It said, it described Linda. She's 31, single, outspoken, and bright. She majored in philosophy. She was deeply concerned about issues of discrimination and social justice, and participated in anti-nuclear demonstrations. Which is more likely, Linda's a bank teller, or Linda is a bank teller who is active in the feminist movement? Well, interestingly here, in order to be a bank teller who is active in the feminist movement, you have to be a bank teller, right? So presumably there's at least as many bank tellers out there than there are bank tellers who are active in the feminist movement, right? The second set is a subset of the first set. So it has to be the case that, that it's more likely that Linda is a bank teller because when you put these two events together, the probability of two events occurring is less than the probability of one of the events, right? And so, but why are we making this judgment? Well, we had all this data, majored in philosophy, single, outspoken, bright, deeply concerned with issues of discrimination and social justice, anti-nuclear demonstration. These are all characteristics that we might associate with or think are correlated with or are representative, perhaps, of somebody who's active in the feminist movement. It turns out all of that is actually kind of irrelevant to the question at hand, but we were led by the representative heuristic. We thought that Linda was representative of somebody who would fit this kind of description, and so we're led to that potential answer. So, we have to be aware of that heuristic. I mean, sometimes the point is with all these heuristics is they are valuable. They are valuable ways to make judgments about forecasts in the absence of much information, but we have to be careful about how they can also lead us astray. So I think it's useful for you to think of a recent decision or prediction that you made. Maybe it's a multiple objective decision, maybe it was a forecasting prediction. Can you think about which heuristics or tendencies that you used in that decision? Did you see yourself in any of these examples that I gave, in any of these heuristics? And do you think any of these biases might have been operating? So what I'd like you to do is pause the video for a few minutes and talk to the people either think about that question or talk to the people that you're working with, and to see if you've got any insights about where any of those heuristics or biases might have arisen in decisions that you've been involved with. For multiple objective decisions, how do you guard against the biases that can arise? Well, if you're the decision maker, one of the things you can do is take a structured decision-making approach. That, in some ways, is the whole point. The whole point of structured decision-making, in some ways, is to guard against, well, it's not the whole point, but it's one of the points, to guard against these potential pitfalls in decision-making that we're evolved to make. What else can we do to guard against these? We can seek review, because that requires transparency and documentation. A lot of the times, if we're transparent and document the ways that we've made a decision, that's going to give rise to people scrutinizing it and possibly recognizing if we have been making some biased decisions because we're relying on these inherent tendencies. What about if you're not the decision maker but you're assisting the decision maker? How can you help the decision maker to guard against biases and tendencies in multiple objective decisions? Well, one thing you can do is alert them to these common tendencies. Give them a short little version of this lecture and talk to them about what the different kind of tendencies you have. Do this at the beginning, at a sort of a training phase or at a phase early on when you're talking about what you want to achieve through a structured decision-making or through the decision-making process, however you're doing it, and alert them to the common tendencies so that at least can be aware of it. I think that's pretty powerful. I mean, it's actually pretty funny, too. I've been in some group settings where we've done this kind of little bit of training ahead of time, and then we've gone into the decision analysis, and people will call people out to say, that's a confirmation bias. You're only looking at the evidence in one particular way. Or somebody will say, that's a status quo bias, or those are sunk costs. So these become powerful things that people can recognize. A second thing that you can do when assisting a decision maker is be clear with them about how they are going to be accountable for a decision. If you're documenting the way in which this decision is made, right away a decision maker is going to be a lot more aware of looking for evidence that may contradict their decision. So they'll be avoiding confirmation biases. They'll be thinking about it from different standpoints. They'll be looking to make sure that they balanced all the different trade-offs and stuff like that. And so knowing that you're accountable often leads to a better quality of decision. Another thing you can do is listen for the words ought or should. When you're working with a decision maker or stakeholders and they're saying, look, what we really should do here, or what we ought to do, or we need to do this, and they're stating sort of emphatically those kind of things, often those are some cues that there might be some hidden objectives or motivations that are going on. And you can use that to explore that and try to bring those out. And then, of course, the last thing you can do when assisting a decision maker is decompose the problem. Use structured decision making. It's meant to break the problem apart into these different components in order that you can think through them independently and guard against the kind of biases that we have inherent in us as decision makers. How about for forecasting outcomes? How do we guard against the biases that arise from the evolved heuristics for forecasting? Well, again, we need to be alert to the cognitive tendencies. Some training and awareness helps. We can review the breadth of relevant information. This will guard against anchoring if we really allow ourselves to think about all of the possible information that's available to us. Pointing out differences between this question and other situations will help us guard against the availability heuristic and the representativeness heuristic. Provide training and practice with feedback. One interesting technique is rather than ask people for their point estimate, for their judgment about their best guess about a probability, ask them about the extreme outcomes first and ask them to explain how those extreme outcomes would occur. So instead of saying, what's your best guess of the probability of persistence, say, what's the lowest it could be and what is the highest could be? And ask those before you've asked the point estimate. Because what will happen is, if you ask people their point estimate first, their best guess first, and then you say, what's your uncertainty around it, you're going to get an anchoring problem. They're going to anchor on that first estimate and not make the uncertainty range big enough. But if you ask for the uncertainty range first, they'll actually think about the problem of, geez, how low could it be? How high could it be? And that'll give them a better estimate of their uncertainty. And then when you ask ask, well, what's your best guess in the middle? They're not anchoring on that. Okay, so eliciting the extreme endpoints first is often quite valuable. So there's another topic here, and that is how groups make decisions. There's a unique set of, well, let me say this first. These heuristics and biases that we've been talking about exist in individual decision makers, right? We as individual humans make those kind of mistakes. It turns out that they also occur in groups. When a group is making a decision, they occur, but some groups are more prone to some of the heuristics and biases and less prone to others. For example, the representativist heuristic. If familiar examples, stereotypes, are available, then groups tend to be more biased than individuals with regard to the representative heuristic. If such stereotypes are not available, then groups are less biased, presumably because they have more viewpoints to think about. The conjunctive fallacy, groups are more prone to this than individuals for some reason. The anchoring and adjustment bias, groups and individuals equally share this pitfall. Okay, so there are some differences between groups and individuals in how these play out, but they all sort of operate, and it's still good to be aware of them all. So groups are prone to the similar kinds of biases and tendencies as individuals, but in addition, there are some special concerns with groups. One of the tendencies that groups have that of course doesn't exist in individuals is what's called groupthink. And the idea here is that the group settles on one preference or belief and stops evaluating other alternatives or even accepting new information. One of the most emblematic case studies of this, in fact, if you Google groupthink, you'll actually get the Bay of Pigs invasion as an example. And so it's held up as an example of groupthink. And the idea here in the Bay of Pigs, of course, was that there had been some plans late in the Eisenhower administration in the late 50s and 1960, thinking about an invasion, a ground invasion of Cuba, based on using Cuban exiles to do this invasion, organized by the CIA. And that had been investigated through military channels at the end of the Eisenhower administration. When the Kennedy administration came in early 1961, in January of 1961, and then this Bay of Pigs invasion occurred in April, 3 months later, there was some well-formed groups within the military and the CIA that had been thinking about this, and this plan started to get elevated and thinking about how it could actually be implemented. What happened at that point, though, is that there was a small group that was really thinking about this and planning of this, and that group became quite cohesive and stopped looking at other information that might occur. There were a couple senators and military advisors that actually were quite critical of this plan, but they were kind of pushed out of the group that was the main group that was doing the planning. So there were some indications that some of the assessments, the forecasting that had been made about how much resistance the Cuban military would pose to this invasion, about the ability of these exiles to carry this out, that the risks were not evaluated fully, and there was evidence to the contrary, but the group really wasn't thinking about it. And so, people use this as an example of the things that can go wrong when group processes are allowed to run their own course. This tendency, there's been a lot of study of this. There's 6 conditions that foster groupthink. One is a high group cohesiveness. Okay, if the group itself feels a strong identity to each other and they're quite cohesive as a group. Another is an authoritarian style leadership, and you can imagine that these two things together go pretty well in military planning circles. I mean, the military tends to be designed around an authoritarian style leadership. And if you have a group that's been working together and has a lot of high cohesiveness, this doesn't tell you groupthink's going to occur, but it's something to look at, okay? It also is encouraged by insularity. If this group does not have access to outside input and alternative plans or alternative viewpoints, then that can foster groupthink. If there's no definitive procedure for decision making, in other words, the group is sort of in a closed room and said, you make a decision, and there's no structure for that, that can lead to groupthink. So when there's not structured decision making in place. When the group has similar backgrounds and viewpoints, and also when there's a complex situation that arises under stress and causes stress. These can all lead to the kind of group dynamics that lead to these kind of failures in decision making. So, I don't think in our natural resources world we have anything that's sort of quite as dire, let's hope not, as this kind of decision. But I think we can certainly find situations, and we often structure situations that have a lot of these characteristics. And so we should be aware of that and make sure that in the facilitating of decision processes, we're guarding against this kind of tendency. And how do we do that? Well, how do we guard against groupthink? Well, first thing was we inform the group about the tendencies and the symptoms, okay? The overconfidence, the rationalization, the pressure for conformity, the illusion of consensus, stereotyping, these kind of things, if we're aware of the tendencies, the symptoms, and the conditions that give rise to groupthink, that helps. Second, the facilitation methods that we use can help break this up. There's some techniques in our 5-day class, our week-long class on structured decision-making, where we go into a lot of the technical details. We have a module that is about eliciting information from experts. And sometimes those experts are in groups, and we're eliciting that information from them in groups. And there's techniques for how you guard against groupthink in that elicitation. One of them is called the Delphi method. And essentially what it boils down to is something I mentioned in an earlier module, that it's often valuable to ask individuals for their judgments first before you start a group discussion. And so actually, in fact, one of the most useful ways to work with a group is first have a phase of individual judgment, where the individual members are asked to think through the problem. Then you share those in a group setting and have group discussion, because there are some very valuable things out of a group, the different viewpoints, the different insights, that's valuable. But then the third phase is that your final judgment is made individually again. So you can guard against some of the group dynamics that often occur. The third thing we can do to guard against groupthink is structured decision making. Again, the more we can decompose a problem and really analyze what's going on in the individual pieces, the more that we may be able to structure decisions and analyze decisions that are robust to all the kinds of concerns that we might have. The take-home message here really is for you to be aware that that's fine. We are intuitive decision makers. There are people who are very good intuitive decision makers. There's people in Department of Interior, in the states, in the tribes that really make excellent decisions based on integrating their knowledge and their innate cognitive abilities as human decision makers. But I think we also need to be aware that there are inherent heuristics that we use, and those give rise to tendencies and biases that may not be optimal. And so we should be aware of those, and we should structure processes that can help guard us against those kind of pitfalls. Now, of course, what we're arguing in this course is structured decision-making. A prescriptive approach to decision-making is exactly that, and is what we're after, and what we're trying to do is guard against these kind of tendencies. But minimally, we should be aware of what they are and think about how we can guard against them.